Today we're going to talk about properties of special parallelograms. And so today we're going to talk about properties of special parallelograms. And the special parallelograms that we're going to talk about today are going to be rhombuses, rectangles, and squares. So you've probably already seen and you already know what they look like, but now we're going to officially learn what special properties they have in addition to being a parallelogram. So all three of these are parallelograms. So if you notice, the definition of a rectangle is going to be a parallelogram, but then what we're going to add to it is it also has four right angles. A rhombus is also a parallelogram, but what we're going to add to that parallelogram is that it has four congruent sides. And then a square is going to be still a parallelogram, but we're going to also include, it's going to have four right angles and four congruent sides. So if you notice, all three of these have all the same properties that we learned for parallelograms. Opposite sides congruent, opposite angles congruent, diagonals bisect each other. But now we're going to add in a little bit more specialization, and then it'll become a rectangle. So for example, the parallelogram looked like this. Oops, it's kind of slanted there. But as soon as you straighten it up and add in the four right angles, then it becomes a rectangle. Soon as you instead have four congruent sides, then it becomes a rhombus. And then the square has everything a rhombus has and everything a rectangle has. So a square, four congruent sides and four right angles. So the first one is the rhombus corollary, and this one just states that a quadrilateral is a rhombus if and only if it has four congruent sides. Well, we just saw this on the previous slide, but now it's officially presented as a corollary. Notice the words if and only if. This is a biconditional, so you can read it backwards and forwards. So ABCD here is a rhombus if and only if AB is congruent to BC, which is congruent to CD, which is congruent to AD. Okay, and this statement is just showing that all four sides are the same. Then the rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. And we just saw this on the previous slide, but again, it's now presented as a corollary. And then again here, they're showing that angle A, B, C, and D are all right angles. And then the last one, this is actually a combination of both the rectangle and the rhombus. A quadrilateral is a square if and only if it is a rhombus and a rectangle, meaning it's going to have four congruent sides and four right angles. So it's a combination of the two above. That shows the relationship of everything. Okay, so let's first fill in all of the properties of a parallelogram. Okay, so right here, opposite sides are parallel. Right here, this is the definition of a parallelogram. Then we learn the theorems, which talks about the properties of the parallelogram. So I'm going to go ahead and try to write them in here. So the first one, the first property is of a parallelogram are opposite sides are congruent. That was the first property. The next property of a parallelogram, opposite angles are congruent. And then we also learned that consecutive angles are supplementary. And then the fourth way, or the fourth property, diagonals bisect each other. And if you recall, all of the converses of these are the ways to prove that a quadrilateral is a parallelogram. So we learned back in 7.2 that a parallelogram has opposite sides that are congruent, opposite angles that are congruent, consecutive angles that are supplements, and diagonals that bisect each other. And then the definition is what we initially learned, that both pairs of opposite sides are parallel. So these are the properties of a parallelogram. Then, if you go into the light blue section, these are going to be the properties of a rhombus. We just saw the rhombus corollary stating that it has all the properties of the parallelogram. So notice the big white square, and then as it gets more specialized, all of the things that we just wrote in the white area are also applying to the rhombus, to this light blue. But what now we add for the rhombus is that it has 4 congruent sides. Another property of a rhombus is the diagonals are going to be perpendicular. This is another property. The second one that we haven't seen yet, we're also going to see that the diagonals bisect opposite angles. So what will happen here in the rhombus, your diagonal will come here and here. It's going to be perpendicular, and it's also going to bisect these opposite angles. So it's going to make them congruent. And we're going to go over to the square. We're going to do the rectangle first. An additional property besides having 4 right angles and all the properties of the parallelogram, a rectangle, its diagonals are always congruent. In the parallelogram, the diagonals only bisect each other. They're not congruent to each other. And now, lastly, the square. The square is going to have all of the other properties. It has all the properties of the parallelogram, the rectangle, and the rhombus. So it has everybody's properties. It's got the properties of the parallelogram, the rhombus, and the rectangle. Notice it's in the overlap area. It's overlapping that blue and that red, because if you think about your art, and blue and red make purple. So all of the properties of everything are a square. So all of these properties are going to trickle down. So like, for example, if you want to see it like in a flow chart, the main name here is quadrilateral, and then from there it'll branch to parallelogram. And then the parallelogram can branch to either a rectangle or a rhombus. But the square has both of these. So you would trickle up and notice the squares at the bottom, and it has all the characteristics of everything up above. So again, start to make yourself a study guide, whether you just use this Venn diagram to understand what all the properties are. Pretty good? Now we're going to see these same properties that I just wrote on the Venn diagram. These are actually now theorems. So the first one is, your book calls it Theorem 7.11, and this is the name of it is the rhombus diagonals theorem. And this one states that a parallelogram is a rhombus if and only if its diagonals are perpendicular. Then the next one for the rhombus, this is Theorem 7.12, and this one is the rhombus opposite angles theorem. So this shows you that over here, the first one, notice all of these diagonals, they form right angles here. And then here, for the opposite angles theorem, notice it's making congruent angles here because they've been bisected. And then the rectangle diagonals theorem, that's 7.13. And this one tells you that the diagonals of a rectangle are congruent. They're not congruent necessarily in a parallelogram, but they are congruent in a rectangle and in a square. So all three of these theorems are all true about squares as well. Because remember, a square has all the properties of a rectangle and all the properties of a rhombus. So now let's go ahead and try some applications of these theorems and these corollaries. Pretty good here. Okay, so for the first example, quadrilateral ABCD is a rhombus. Find the measure of each angle. So here we're going to use the properties we just learned. We know that opposite, all the sides are congruent in a rhombus. I also know that the diagonals are perpendicular when it's a rhombus. And I also know that opposite angles have been bisected. So that's congruent to that, as well as this and this. So this is just filling in all of those theorems and corollaries that we just learned. So now that I've labeled my picture, now I can go back and find all these angle measures. So the first one is ACD, and ACD is this little angle right here. And I know that that angle has been bisected, so this is going to be 62 degrees. Color. So this one is 62. DEC is right here. And you know that the diagonals are perpendicular, making this one 90 degrees. And then we have EDC. EDC is over here. So what I need to do here is I can do several things. If I know that I have a little triangle here, let me highlight it. I've got a triangle going on here. And if I know that this angle is 62 and the one here is 90, I can realize that I can just do 90 plus 62. Subtract that from 180, and the angle they're asking me to find is 28 degrees. Now I could also realize I could find the total of this angle here and then subtract it from 180 and then divide it by 2. There's lots of different ways you could go about finding these, but that would be one way. And then the last angle they're asking us to find is ABC. And ABC is up here. So what I'm going to do here is, if I realize that this one was 28, and this one's 28 because it's bisected, over here these will also be 28. So I'm going to do 28 plus 28, and I get 56 degrees. Again, I could have added up 62 plus 62, get 124 for this whole angle here, and then subtract that from 180 and get 56 as well, because these are going to be supplements here, these two. So you're going to be using all of these properties to find missing angle measures. So ABC here is 56. Now we're going to answer questions about a rectangle in example 2. Pretty good here? All right, let's try 2. It says quadrilateral MNOP is a rectangle. So this tells me that opposite sides are congruent because it's also a parallelogram. I also know my diagonals are congruent. So it's telling me that if this little piece here is 12, then this piece is 12, this piece is 12, and so is this one. I also know that a rectangle has 4 right angles. So let's go see if we have enough information to start answering questions. So it wants me to find the measure of angle PON. PON is this little right angle right here. So it's 90 degrees. PMO is going to be this angle, only part of it. So what I need to do here is, if I realize that the original big angle here is 90, I'm going to do 90 minus 29, and PMO is 61. In a rectangle, the angles aren't bisected. That's only for the rhombus and the square. PL, well, I already labeled it because I know this diagonal was bisected, so it's 12. And then to find the length of the whole diagonal, the MO, I'm just going to add 12 plus 12, and it's 24. Remember, diagonals in a rectangle are congruent. And we have one last slide. So we are going to make it through all of the examples. So potentially, if you wanted to do all of the homework this weekend, you could. All right, so let's go ahead and do example 3. We have a quadrilateral here, and it's telling us that MORE is a square. So I know the properties of a square. I have 4 right angles. I also have 4 congruent sides. I also know that my diagonals are congruent because it's also got the properties of the rectangle. I also know the diagonals are perpendicular. So let's go ahead and see what we can figure out. So it's telling me the length of ME is 7x minus 3, and MO is 6x. Well, this is a square, and I know all sides are congruent. So to find the value of x, I'm going to set 7x minus 3 equal to 6x. I'm going to get my variables together. So I'm going to subtract 7x. Negative 3 equals negative 1x. Divide by negative 1. And x equals positive 3. And now lastly, they're telling me that MT is 4x and TE is 3x plus 2. Well, I know because a diagonal and a rectangle is congruent, I know that all of these pieces here after they've been bisected are also congruent because the property of a rectangle and a square are the same. So I'm going to set 4x equal to 3x plus 2. Subtract 3x. I get x equals 2. Now this time it didn't ask me to just find x, it wants me to find the length of OE. Well, OE is the entire diagonal. So once I put it into 3x plus 2, 3 times 2 plus 2 gives me 6 plus 2, which is 8. So this little piece here is 8, and so is this piece. So the length of OE is 8 plus 8, and it's 16. So just be very careful of what the question is asking for. Again, make sure if it only asks for x, and you put that in, or if it asks to find the length of either the bisected segment or the entire diagonal, just remember what you're plugging it into. So again, my advice to you is start getting a study guide and keep track of all these properties. We're also going to talk about 2 other types of quadrilaterals that are not parallelograms, and those are going to be trapezoids and kites. And we'll talk about that on Tuesday. And then we'll finish up the chapter and then begin reviewing for Friday's test. So after my last makeup on Monday after school, I will release your quizzes so you can use those to study for the test as well. So I'll probably release those on Wednesday so you can start using your quiz as well. Any questions? All right.